This meeting is being recorded.
In problem 10 from chapter 5, we are given some structures of amino acids, histidine, cysteine, proline, aspartic acid, and the first structure in the box, that's glycine. So we're told a little bit about what amino acids are. They form peptides, and amino acids can form longer chains, can form proteins, etc. So we're asked here to assign a configuration to each of the four amino acids shown below and determine which one is the exception. And then the follow-up question for part B here is to explain why glycine is considered achiral. So let's take a look at the four structures on the right, and let's assign priority to the chiral center. So we have this carbon here. Our highest priority group would be that nitrogen. Then we see we have second highest priority over here because this carbon's bonded to 3 oxygens. Then we have number 3 here, and we know that we have on our dash a hydrogen. So 1, 2, 3 for histidine would give us an S configuration. Let's take a look at cysteine here. So again, the number 1 priority is on our nitrogen. This time, we're going to look at the carbon that's bonded to the sulfur here. That would have higher priority because sulfur is heavier than the oxygen that we see over here. So we'll take note to that and see that this is an R configuration. So we might have found our exception already, but we'll keep going. Now we have proline, so we'll follow the same trend. So this is our highest priority group here with the nitrogen. Oh, we forgot to mention, we know we have our fourth group here with cysteine, as we have our hydrogen here on the dash. Our second priority will be over here, and then going from this central carbon, our third would be here. So 1, 2, 3, we have S-proline, and then we have our aspartic acid here. So, so far we have 2 S's. So if aspartic acid is also S, then we'll know that the exception is our cysteine. So here's our chiral carbon, highest priority on the nitrogen, second here, third over here. So we see 1, 2, 3. So we have 3 S configurations for these amino acids. So our exception then would be our cysteine here is the R configuration because of that sulfur, that thiol group. And then let's take a look at part B here. So we have glycine and the R, the side chain on our alpha carbon, our chiral center here, and all the other amino acids, right? So we would have our highest priority here. We would have our second highest priority here. But then we have hydrogen, we're told, is our R group. And we know that our fourth group here is also a hydrogen. So since that R or side chain is a hydrogen, we'd see that that carbon is not actually a chiral center because it has 2 of the same groups.